Good evening, everyone. It's a pleasure to be here for this great conversation about a topic that is so relevant for our time, the impact of artificial intelligence, and most importantly, what truly makes us human. You just heard an introduction to Neil Lawrence's book. And for those of you who didn't catch his interview earlier, he needs little introduction, but it's worth highlighting that he's a professor of machine learning at the University of Cambridge and a senior researcher at the Alan Turing Institute. He is one of the leading voices in the study between the study of the relationship between artificial and human intelligence. Joining us as well, right to my left, is Bernardo Caldas. He is an expert in artificial intelligence and co-founder of Data Science for Good Portugal, an association dedicated to promoting the positive impact of AI on society. With extensive experience in applying AI across various industries, Bernardo brings a more hands-on approach on this topic and how these technologies are actually implemented and their world-life impact. The goal of this discussion is not to repeat some of the topics covered already earlier, but rather to go deeper into some of the key questions raised in the book, but also bring in Bernardo's perspective from the field. Neil, good evening. I'll start with you. In your book, you argue that AI is often mistaken for intelligence. Could you elaborate on why you believe AI is fundamentally different from human cognition?
Yeah, I think so. I got into this field because I was interested in how technology could be used to solve problems. So for me, the whole notion of intelligence is a side question. Intelligence isn't a problem. Yes, we would like to make intelligent decisions, I would agree with. So when I think about what is intelligence, from my purposes, it's using information to make decisions. Now, the fundamental difference between machine intelligence and human intelligence in that regard is the rate at which we can access information. So I'm talking, and the rate of information I'm speaking about, we can measure. It's not like intelligence. This is an absolute. We can measure it in terms of information theory. It's about 2,000 bits of information per minute. So a bit of information is how much information I give you if I toss a coin and I tell you whether it's head or tails. The machine, in contrast, is, if it's 10 gigabit Ethernet, is going 600 billion bits of information per minute. That's a difference of 300 million times, which is the same as the difference as between walking pace and the speed of light. So it seems to me a simple absurdity to talk about these two entities as if they're playing the same game. You know, you're talking about the difference between a photon and me walking to work, right? This is totally different. And of course, the capabilities of something that's effectively moving at light speed is well ahead in some regards than ours. But it's not all about speed. And a lot of our intelligence is just dedicated to our context that's operating in a certain way. So for me, there's a difficulty in how you want to use the word. If you insist on calling machine systems intelligent, then I think we have to look at a lot of other systems and also describe them as forms of intelligence, including, for example, our ecology. So I don't mind. People can either use it in a way that is for us and the machine, but then they better start talking about trees as being intelligent as well.
Right. Bernardo, I'm sure you're eager to comment. And still on the main topic of Neil's book, from your experience, do companies and the general public understand these limitations we were talking about? Or is there an inflated perception of what AI can actually do?
there's obviously an inflated version of it. Because there's interest in inflating it. Obviously, if you promise it will be more intelligent, then it will be, you can sell more. And so you have an interest in selling more than you can actually achieve. But I do think that fundamentally, there is a lack of understanding of what the systems are actually doing. And I think the community tried at the beginning to try to deflate those expectations by saying that they are stochastic parrots, that they're just repeating words. But it failed to basically then explain if these systems are, by definition, just working on language, then why do they seem so powerful? So I think that the hard thing about AI right now is that it's hard to reconcile these two different ideas that, on the one hand, they are indeed just manipulating language, therefore not displaying lots of the intellectual capabilities we have, therefore being very different from our intelligence. On the other hand, doing something that so far we thought was inherently human, which is producing language and being able to communicate. And these two things happening at the same time make it very hard to explain to people that there are limitations. Because when we see a computer communicating in the same way that we do, our immediate instinct is to say then the process by which it got to that language is similar to the human one. So it must be reasoning, it must have empathy, it must be connecting to us, and that's all false. That's not the way that it works. And so this fundamental difference in the output, which is language, and like the current generation of AI systems, these large language models are great at producing language similar to ours. This idea that this language being similar means that the process by which we get there is similar, creates this fundamental difficulty in explaining the limitations of the systems. Now, in the real world, the same thing happens. So we start to see companies...
An example, yeah?
Yeah, we start to see companies promising to replace customer support organizations, because now you have a system that can answer your queries. Recently in Portugal, we have an idea to replace emergency health services call centers with artificial intelligence. Like assuming that now, obviously we have a system that understands everything, it understands the needs of the person calling, it has empathy, it can deal with things it never heard before, with different accents, with different problems. And now we tend to feel that, yeah, if we have a system that's able to produce poems in the style of Camões about Pavilhão Carlos Lopes, then it must be able to understand everything that a human could say when calling an emergency health services. So I think that, yeah, it's great at some things, it's really bad at some other things, and we're lacking intuition to feel which is which.
Neil, any comments? Addition?
Yeah, no, I think Bernardo's got it exactly right. And that's part of the problem of why it's difficult to deploy in practice. When I always think when like big tech CEOs say, none of you can understand this technology, what they really mean is, we have no idea how to design and build this technology. Yep. It's kind of like they're giving you a car. Like cars came about over some period of time. The steering wheel evolved, whether the indicators on the left or the right, these sort of things appeared over a period of time. And they mean that we all understand how to use a car, even if we don't understand how the car's working. And with computer technology, that's something that is a little bit, it seems to be harder in deployment because they're trying to do a one-size-fits-all thing. And so they kind of try and give you this interface where there's all these buttons and knobs and switches, and they say it can do all these amazing things, but it's very difficult for people to understand in the way that we want to understand technology, which means that we understand if I do this, it will do this. And if I want to change how it's working, I have to do that. That's the understanding we need. And I do believe that this technology is straightforward enough for us to be able to get there, but it sort of seems that large companies, they're struggling to understand exactly what to do with it. So they're struggling to understand how to design it in that way. And then they tell us that we can't understand it, when really I think it's them that doesn't understand us. Sorry, that was a...
And also on that point, Neil, there's a lot of talk about how AI could become this entity that could one day think like us. How realistic is that?
Well, it's not, I mean, that's one of the points in the books. It will never think like us, right? Because we are a product of our context, yeah? So the way we operate is a consequence of limitations on us, including this communication limitation. right? The fact that we think consciously at a certain speed is to do with how rapidly I can say something. There's no point in my thinking getting too far ahead of expressing the notion that I'm trying to share. So we've evolved in our circumstances. So it won't think like us, but I think the interesting thing that people are doing is that they've made it look like that's going on. They've emulated us. So I use this word emulation to describe that. It gives the outward appearance that it's thinking like us. It behaves and responds in ways that most people would struggle to judge that it wasn't a human. And that's a really interesting and challenging situation for technology to be in, because it means it can misrepresent as being one of us, even if it isn't one of us. And I think Bernardo's example of the emergency room thing is, that's a particularly, so what are the morals and ethics of it? First of all, you would want it to be clear when it's a computer and not a human. And then also you've got this sort of situation, think about emergency calls and when someone's in enormous distress. And then, how can you get the right relationship between the recipient and the caller in those cases? So that's certainly a case where I would think that the ability to actually think like us remains very important.
Very important. Bernardo, as someone implementing AI, do you see resistance from people when it comes to adopting AI-driven tools? Are they afraid of automation or of losing control?
The answer is yes to all of the above.
Okay.
I think that there's this mix as well of excitement and fear that's hard to reconcile. To some extent, lots of the work we do is not really creative work or really that intellectual. We all have lots of tasks we do that are repetitive by nature. Therefore, whenever we see a machine that's able to automate those, we start to get scared. At the same time, whoever experienced the benefits of being able to delegate things they actually don't want to do, like in Neil's previous example of the nurse being able just to do the things they want to do, I think there's lots of excitement. I do think that there is the lack of control once you start to see that the machine sometimes fails in ways that you cannot predict. Previously, we were used to interacting with computer systems that were programmed to work in a certain way. And whenever they failed, we call them bugs. They didn't work because someone did a mistake in encoding the actual task or the goal or the way to go about solving it. But now we have a system that's inherently chaotic. It's hard to predict. And that's part of what makes it hard for people to adopt this technology fully, is that you start interacting with it, you have this perception that it's great, until you start to reach its limitations, and then suddenly, those expectations deflate, and you think this is actually useless. And the truth is somewhere in between. So I think that the way to make these things work in practice is, again, by not over-promising, by not saying to people that this will be the thing that solves everything, that will replace everyone, and that's the full intelligence. No, it has the ability to do things that previously we could not explain a machine how to do, because they're not as programmatic as some of the other tasks we have, and therefore it's great to automate some other things. But I think that promising the right amount, adjusting the expectation by talking about the potential, but the true limitations, and to some extent giving people an intuition about why these limitations exist, gets rid of both the overexcitement, but also the unreasonable fear that sometimes exists.
A question for both of you. Regulation is definitely a hot topic, and going a little deeper than earlier, some argue that strict AI laws will stifle innovation, while others say they are necessary for ethical AI development. Where do you guys stand on that?
Can I go first?
It's mostly a Twitter argument at the moment, isn't it? All the experts are on Twitter. If only, X, whatever it's called. And it's amazing how many of these experts have utterly failed to engage with the practicalities of what regulation, enforceable regulation, looks like. It's almost like, I don't know. I try not to be a grumpy person, but I am a grumpy person, really. And, sort of, as I wander around and I see people doing things that annoy me, I think there should be a regulation to stop that. This person shouldn't be on their bike on the pavement. This person, that cars, and wouldn't it be great if the world would, but that's not how it works, right? certain limitations, there's costs to regulation. And I think you have to really get close to the deployment and the issues that people are facing. It's a little bit, it's almost the same answer Bernardo gave to the deployment of the technologies. A lot of this is about giving experts. In the case Bernardo was talking about, it's, the nurse trying to use the technology to write up patient details. In this case, it's the regulator trying to understand what's going on the ground, and if there are sort of slight changes to the way that they're approaching. This sort of example we often give in the UK, and we had some nice examples of success with this. We worked with the Department for Education to put out a notice which sort of gave some guidance to how you might use AI in schools. And then the guidance is evolving. It's not legally binding, but it's a set of guidance that said, look, we think it's fine if teachers are using this to support them in making lesson plans. That's a useful thing for teachers to do. And just a little bit of guidance like that, that's not official regulation, is sufficient to support the teachers in steering them in the right way. So I think the problem with the regulation argument, it's come because there's been some very clumsy, rapidly deployed regulation. That's giving regulation a bad name. Whereas we all know that the answer, a bit like Bernardo's previous answer to your, the truth is somewhere between.
Right.
That good regulation enables rapid, safe innovation, and bad regulation either stifles regulation or has unforeseen consequences in distorting the market.
Bernardo, clumsy regulation?
Yes, lots of it. I think that's part of the problem. Part of the problem is that our regulators don't really understand what's happening. And if people like Neil admit that we have a lack of understanding of these actual systems and how they work, and we're still discovering, like in the OpenAI example, where people didn't know what was going to come out of ChatGPT. Regulators have a bigger challenge even, because from the backgrounds, from their expertise, it doesn't really match the thing they're trying to regulate. Therefore, they are sometimes, again, overly ambitious in the way that we try to regulate. I think it's more than fair that we have an AI Act in Europe saying that the use of AI for doing social scoring is unacceptable. I think that's totally fair, and I think it's helpful that someone says that. It's helpful that someone says that AI should never be used for making automated recruitment decisions. I think that's fair as well. That's the sort of regulation where you're tackling the use cases and explaining these are the sorts of things that we as a society do not want to have a machine deciding for us. I think that's totally fair. However, it doesn't stop there. And we start by saying that, and then if the computation capability of the machines used to train a given AI system are bigger than a given threshold, then there are an additional X amount of pages you have to write. And this is ridiculous. First of all, because of the DeepSeek example, where now you can train things for cheaper, therefore you're below the threshold, so you're safe. And it makes no sense. You're trying to regulate the computer or the word processor, like in the examples that Neil gives in the book that are wonderful. You're trying to regulate the technology and not its use, which is always a failed endeavor. And I think that our regulators tend to try to do that because they don't understand, they get nervous, they try to over-regulate, and then it gets clumsy.
Yeah, so I'll do a bit of, I agree on that, but then I subdivide legislators from the regulators. I think of in the UK, we would call the regulators the people who are charged with enforcing the legislation. And so I think things particularly seem to be going wrong with the legislators. And the examples Bernardo just gave, I would argue that social scoring is quite likely covered by GDPR already.
Yeah.
And so where these things, there's a lot of cases where these are covered by existing legislation, and it's sort of unfortunate that, of course, everyone wants to be claiming. That's, I think, the sort of problem we've got, where the legislators want to claim ownership of this space, and rather than thinking it through carefully and going, oh, hang on a minute, most of this is roughly covered, but what we could really do with is some clarity on who's doing what, like should GDPR be also taking into account. That's the type of thing that we've been attempting to do in the UK, or certainly were attempting until Rishi Sunak got very excited about existential risk of AI. That was the UK AI policy. And I think that's a sort of really sensible way to go. But yeah, so just a slight difference. I feel it's the legislators that get overexcited rather than the regulators.
Yeah. If I can just say one thing about this, which I do think that we're not paying enough attention. I think that in the book, Neil, you also cover, for instance, AI being used, or machine learning being used, better said, in social networks, for instance.
Yeah.
And the fact that they're optimizing for our engagement and playing tricks with us to make sure that we're addicted to using it. And I've been thinking a lot about this because there is no way to regulate this use of it.
Yeah.
But there is ways of trying to regulate giving consumers more choice about how to go about using these technologies. I think that this is a very tricky thing because we tend to say, like, is this acceptable or not, versus thinking of how can I empower people to make better and more informed choices about how to use technology. I think we tend to over-focus on the technology and not to make sure that people understand and are able to choose how the technology affects them. And I think that's a shame.
I think that example thought about a lot, and in some sense, that's why we worked on these data trusts a lot, because it's one of these examples of power asymmetries between the social network itself and the users, because we can withdraw our data, but then we just lose things. So that's an example where I felt for a long time we don't need new legislation, but we need institutional entities where we can settle our data in these entities we think of as data trusts. And then that data trust can have the argument with the social media outlet. Now, it turns out to be just very difficult to bring that into practice. But one of the interesting things about it is it is mentioned in the Digital Markets Act, this is an approach. But in the UK, it certainly wouldn't need new legislation to bring that about. But one of the things I think we face as a society, which is very interesting, if you compare it to, say, certainly in the UK, Victorian industrialization societies, there was a lot more community work to deliver vehicles to support individuals. So if you look at the sort of problems that people were having in their community, like they didn't have fresh water, you saw the emergence of water corporations, which were like shared collaborations in the community to bring about a water supply. And I think one of the challenges we face is, combined with these digital technologies, that our notion of community has somewhat dissolved. So we're struggling to sort of come together and collaborate to work in some form of cooperative to actually exercise our existing rights to our benefit, which wouldn't require additional regulation.
Definitely. And Neil, in your book, you mentioned that the way we use AI tell us more about ourselves than about the machine. What do you mean by that?
Well, I guess what I'm saying about that is there's a fundamental narcissism to our intelligence, which comes about through this bandwidth limitation. So in order to sit here and communicate, each of us has to have models of what other humans understand. And we have a fascination with other humans. So one of the things I think in the future, this idea that there won't be any jobs is ridiculous. Humans are fascinated by other humans. There'll be an infinite amount of work in humans watching other humans doing things, right? That's what football is, basically. But what I think that when we talk about artificial intelligence, I think in the most unhealthy ways, I think what you're seeing is very similar to what I think you see with the sort of Greek gods. So, and I think there's a reason for that, right? So the Greeks are sitting there thinking, well, there must be these powerful beings that's brought this world around, so they must be gods. And in some sense, those beings are like what we think of as AI today. And then you get this really interesting effect, which is quite disturbing for what Greek culture must have been like, is that people sit around and say, well, if you were the all-powerful king of the gods with all this, unimaginable power, what would you do? And then they're like, well, you would really try and sleep with all the beautiful women you met. Because that's basically what Zeus does. And your main issue would be your wife finding out, because that's really what Hera does most of the time. So it's this sort of utter lack of imagination about what it would mean to have such power, which is clearly clearly must have been a male-dominated society at the time. It's like, oh yeah, that's what I would do. And you kind of see the same thing going on now with what we're hearing about AGI. When we're hearing about the existential threat, the people who are telling you that are the ones who would do that if they had such power. And notice, it's always men again. So we've got back to sort of men expressing themselves through their very limited empathy for what an all-powerful being would do. So that's what I mean by that. You see our projections of these future being reflections of the limited empathy of people who are in power. Now, if you fast forward with religion, you see it's much more I mean, not religious myself, but you see religion becomes much more introspective. So you sort of see modern religions take this notion of an all-powerful God to sit there and think, well, what does that mean for me with my failings, and how can I try and do better? And I think we should probably try and do the same journey with AI, like move away from this Zeus-like model of what this existential AI would, this existential threat AI would do, more to, well, hang on a minute, if those are the valuable things about a machine, what is valuable about us? And it becomes much more about the sort of things that you hear less about in the Greek gods, like bringing up children and reproduction and dying and all those things that are specific to who we are as humans, but these immortals don't have to worry about.
Right. And speaking of breakthroughs, we've seen a lot of hype around China's DeepSeek. We've talked a little bit about it already, and its latest AI models versus its rival ChatGPT, obviously. Does this represent a real step toward more human-like AI, or is it overblown? Who would like to go first?
I think Neil already answered that. I think DeepSeek's main contribution is it's now much more efficient, needs less energy, needs less GPUs, so the computer chips that are used for this, and that's great. And again, that will make it cheaper, so easier to use for the places where AI can actually be helpful. That's great. It doesn't solve the fundamental limitations of AI systems. So it in no way makes the way that it thinks, the way that it has empathy for us, our goals, any better than the current generation. So I don't think that there's a step change there. There are people trying to propose ways of addressing those limitations, but I think that what we're seeing right now is just doubling down on the current set of AI systems, the current architectures, and that will lead us to systems that are great at producing language, that are great at seeming intelligence, at producing plausible answers, but yeah, not really adhering to the truth, whatever that might be, or being really similar to the way that we think and reason, I think.
Right. Neil?
Yeah, I think one of the things I agree with everything Bernardo says, and just to add a thought I've had on DeepSeek, one of the things I'm fascinated about it is how they organized their team, because I think it's 100 to 200 people who've built this thing. And, the quality of work, I sometimes say it's like these American AI models, they're like these big hot rods with these massive V8s, whereas DeepSeek, when you read the engineering, it looks more like a Mercedes AMG with everything carefully thought through and pieced together beautifully to make it more efficient. And I'm super curious about, just having worked in Amazon in a big tech company and organized teams, I know how hard that would be to do, to build a team that can create that sort of thing when you're at the level of 100 to 200. If you're building something with 35 people, that's relatively easy. But once you cross this threshold of 70-odd people, it's extremely difficult to piece your team together such that they can pull this project together in an engineering way. That's why it's hard for people to build Mercedes. And that's almost become the thing I'm most fascinated about, is how do they set up as a team? Because I think that's one of the things that is radically going to change with this technology over time, the way corporations organize. Because corporations organize around information infrastructure, around how to direct and share. And, I talk a lot about it in the book. And this technology really can dramatically affect your information infrastructure. And I'm partially curious, to what extent are they using the AI technology to organize their team? Maybe that's fantasy, maybe they're not. But it's a question I'm super interested in. So I'm again interested in the humans. Apologies.
Definitely. Before we wrap up, one final thought, and I definitely want us to end on a positive note. And let's not focus on AI risks for now. What excites you the most about AI's future? Bernardo?
I think that in the very, very short term, with the current capabilities, the fact that we can now organize information in a way that was never possible before. The amount of information that's stored in documents and PDFs and everything that's spread about, and it's really hard to access. I know that this is very small, But this is like, for me, the best thing about current AI systems is that I can take unstructured data. I can go and see what, Portuguese members of parliament said at the beginning of the century. And now try to reason what were the most important topics, what were their proposals, did they work out? I can use this, for instance, to see, well, has a given political party said something during a political campaign and then voted differently in the parliament? And I have a system that can do this automatically and help us understand a bit more about how the world works in the things that are not structured in tables, and can help us quantify things that previously were only qualitative. I think this can bring an immense benefit to the current state of society that we are completely ignoring, I think. So I should have said healthcare or education or something else. For me, it's just and I think on topic with the whole celebration of Por Data today, just organizing information in a way that surfaces more what's currently happening and improves the public discourse about the reality. I think that would be amazing.
Thank you. Neil?
So I'm again thinking about an example from the International Computer and AI Network, and this one involves a longtime colleague of mine, Shiramania, who's in Nyeri University in Kenya, and he's been working with Thomas Schultes from the Swiss Alps supercomputer to combine rainfall data they have on the ground in Kenya, which it's not high enough quality to be directly inserted into the weather systems, but they fix it with some machine learning processing, with the latest GraphCast model from Google that predicts weather more accurately than ever seen before, to do rainfall predictions across Kenya at higher accuracies than have ever been done, which should allow these rainfalls, and that's the next bit, another very hard bit, to get those rainfall predictions to the farmers so that they understand when to plant. Now, probably not many people are involved in farming here today, but of course, 150 years ago, we probably all would have been involved in farming. And one of the most critical things is knowing when to plant relative to the rains or when to spray. So that information, that's transformational, and it's coming about through a worldwide collaboration between a great technology produced by a big tech company with some great on-the-ground processing of machine learning, of community projects around rainfall monitoring, to deliver something that could be of enormous benefit in the way that Bernardo just described.
Gentlemen, thank you so much. Thank you for bringing in your insights. We're over time, but I'd like to thank everyone.
Thank you.